We explain the impact of the scientific revolution. As Europe reopened itself up to the world through exploration, war, and trade, they began to bring home the knowledge from their ancient Greek and Roman ancestors that had been collected in Eastern libraries. Then the Renaissance pushed this rebirth of classical foundation knowledge and reignited curiosity for explanations of the universe, beyond the teachings of the Church. It allowed for new scientists to question the theories of old scientists like Ptolemy and Aristotle. The classical theories on the universe had been widely taught for 1,000 years and accepted by the Church because classical theory and church theory matched each other. For example, both taught that the heavens were fixed and that the earth was the center. Polish astronomer Copernicus offered up a differing view of the universe, a heliocentric model where the earth and the other planets circled the sun in the center. This theory chipped away at the common-held beliefs of a geocentric universe. Tycho Brahe set up a long-term observatory experiment to keep records of the movements of the planets and the stars, and his assistant Johann Kepler calculated the data to prove this theory, but also added his own theory that the planets moved in an elliptical orbit, not a circle. Galileo Galilei would take it a step further and build a telescope that could visually prove the theories. Then Galileo was attacked by classical scientists and the Church. He was pulled in front of the Inquisition in 1633, where he was forced to recant his theories, and publicly announced to the world that the earth was the center and it did not move, or he'd be put to death. He left the court, being sentenced to house arrest for life. As he left the court, he was heard to mutter, "And yet it moves." This encouraged other scientists to open up the process of scientific discovery. Many sought to break the control of the Church over science, using inquiry and analysis before arriving at the answer, rather than starting with the answer and making the data fit. René Descartes used deductive reasoning, using a general theory to prove a specific observation. Francis Bacon used inductive reasoning, which went from a specific to a generalization. This system of analysis would form the scientific method, and their calculations would form scientific laws. The new method of confirming and testing results would lead to breakthroughs in medicine, anatomy, surgery, and health, refuting the Greek philosopher Galen. It would lead to the birth of new scientific tools like the microscope, and the exploration of elements that led to the testing of compounds and laws of temperature, pressure, and matter, defying medieval chemists and magicians who believed they could use chemistry to turn any of the elements into gold. One of the revolution's most famous members was Isaac Newton, who began theorizing the theory of gravity at age 24 when he wondered why the planets moved in a formation. When he saw an apple fall, he wondered if it fell at the same force. For the next 20 years, he developed the mathematical language of physics called calculus. He explained the universe and the laws of motion that led into an age of invention.